capital expenditure, it's operational expenditure. We have applications, we have the agility of the cloud. Organizations pay only what you use, consumption-based. Private cloud, you have full control over your security, over your resources, everything, but you also have full responsibility over that. Hybrid cloud gives you the best of both worlds. You get flexibility, you determine what makes the most sense to run your applications, and that's hybrid cloud. Now let's talk about the types of cloud services that run in those different models. And really now we're going to focus in on the key terms: IaaS, PaaS, and SaaS. And really it's a level of responsibility. So when you look at infrastructure as a service, if you look at where it's governing on this slide, the physical data center, that's us. The physical networking, firewall, and security, that's us. The physical servers and storage that run your environment, that's us. Now what are you responsible for? Operating systems, the applications that run on top of them, or the configuration and development of those applications. That's infrastructure as a service. Now, if you look at platform as a service, guess what you don't have to worry about? You don't have to worry about the operating system. There's definitely a compute resource behind those PaaS services, but you don't have to worry about it. Then you have SaaS services, where generally speaking, you just have to configure that client to work with it. So if you use any streaming media today, if you subscribe to any of those, watch movies on planes or download that stuff, guess what? Most likely using software as a service. The great thing about software as a service, it's a very predictive cost model. Generally speaking, it's a $10 per user per month kind of thing, depending on what service you're using inside of there. Now, I like this slide because it kind of lays out the story, but really most of you have probably seen a slide like this of how we describe the shared responsibility model. So Garrett brought that up. It's a huge term, right? If you're on-prem, what are you responsible for? Everything that's in green. Well, that's everything on the list that we have for us to use. Infrastructure service, what are you responsible for? For that virtual machine, that operating system. So do I have to patch it? Yep. Do I have to back it up? All those things. IaaS is what we're responsible for. If you look at PaaS, all you have to worry about is developing your application. Developers still develop, and they still have to have right access to it. Versus software as a service, guess what? They just have to worry about data and access. Now, generally speaking, at a real high level, when you move from infrastructure service to platform as a service, from IaaS to PaaS, you're going to save money in your cost consumption model. Why? You're consuming less resources. You're just leveraging the application. You don't have to worry about the operating system or the virtual machine. You don't have to worry about maintaining that from a cost perspective. We see a lot of customers now that are in that kind of crux. Do I just take my VM from on-prem and do what is called a lift and shift and move it into a VM in IaaS? If you do that today, I'm willing to bet tomorrow you're going to say, you know what? I don't want to run that VM anymore. I don't want to pay for that virtual machine anymore. I want to just re-architect or refactor or redesign my application into a platform as a service so I can get out of that business. I don't have to worry about that anymore. And you're going to save money with most Azure services by doing that. A lot of our customers today are looking at, hey, I want to migrate to Azure. Moving that VM, lift and shift, is generally not their first option. It's the option of last resort. In other words, you know what? I can't get the application to work the way I need to just yet. I'll move the VM up because I need to leverage cloud resources for it and whatever else I want to do. And they're going to leverage infrastructure, but we see them on a journey. And now it gets interesting when we start talking about platform as a service. This means your organization has the skill and the developers to be able to write and work with those applications. But guess what? We have software as a service inside of Azure as well via what is called the marketplace. So the question becomes is, do I build my solution or do I buy the solution? Something in SaaS to leverage inside the cloud services we have. So when we look at this, folks, it's really designed to solve the problem and how you want to solve it, what's going to be the best, and what is it going to cost you to do all of that. Now, a couple things I love about this slide. First off, from a Microsoft perspective, all those services can talk to each other, from on-prem to IaaS, PaaS, and SaaS. These services can all leverage each other. More to the point, Microsoft is the only cloud company today that does all four of these. Our DNA was built on Windows servers. We leverage IaaS, PaaS, and SaaS. So when we think about this, we're the only company that understands all four modules, or all four modes of this. The cool thing also about our company, everybody goes, well, when we look at one of our biggest competitors, Amazon, they jumped out to a huge market lead. And in recent years, we've caught up, and it's going to be a seesaw battle for the next, probably as long as our lifetime is, that's going to be there. But where did Microsoft start? We started as platform as a service. Why? We're a software development company. Why do you think we developed the Azure PaaS services? For our developers in the company to get more efficient, more agile, get global reach, customer latency, get elasticity, all built into the services. It's in our DNA as a development company. Where we see the organizations going in the world today, and this is Gartner and Forrester and any research organization, people are leaning towards PaaS. And they're leaning at leveraging either Azure or Amazon to do that. But that's when you look at those general modules, it's in our DNA, folks. Our PaaS story is incredibly strong because, and not to belittle any of our competitors at all, but it's incredibly strong because it's in the DNA of our company. We were born to be developers. Everybody's like, what's Microsoft do? We're a software development company. And so we have a great platform, and we understand because we built things for on-prem before we built Azure. Even though we had cloud in 95 with the Windows update, we have the ability to work with this. And so when I look at comparison, just as a summary of all of this, IaaS, infrastructure service, it's a flexible cloud service because really it is, hey, I want to move that machine from on-prem into my cloud environment, and all you have to do is configure the hardware. From an IT pro standpoint, this is where a lot of people start with cloud. Hey, that application's familiar. I know that operating system, whether it's Linux or Windows, and oh yeah, I did say Linux. We'll talk about that in Module 2. We also have platform as a service where we just focus on developers. Developers like to develop. Now, the cool thing about this, when we think about PaaS services, I'm starting to get these questions again, Garrett. They're starting to go, wait a second, PaaS is going to take my job. What's going to happen when those folks come into PaaS? Well, guess what? You still have to have governance. You still have to have security. You still have to architect networking. You still have to architect storage. You may not have to worry about those virtual machines anymore. And guess what? When IT pros learn that, they're like, wait, I don't have to worry about updating? No more Patch Tuesday in a PaaS service? No. Who does the patches in our servers if you're running on PaaS? We do. That's our responsibility to make sure those servers are safe and secure when you're running those workloads inside of it. And then, of course, we have SaaS, which is pay-as-you-go. So when you look at all those models, you got to keep them straight. And for the exam folks, you have to keep these straight. They're going to ask you on the exams, hey, what's the difference between this? Or give you some scenario. What would you use, IaaS, PaaS, or SaaS?
You know, that's a really great question, Matt. We actually have a lot of activity happening behind the scenes in the chat happening here, people that are attending. And there's a great question, and I'm curious to know this too. How do you personally keep IaaS, PaaS, and SaaS straight in your mind? I mean, these are all potentially new terms for us. So how would you look at those three and just separate them and keep them in your mind as how you look at them?
So I would love to take credit for what I'm about ready to show you, and it's been on the internet for a long time. But let me ask you a question, Garrett. Do you like make-at-home pizza? Is that a fun family night? You got 5 kids, and I mean, I know you want to do pizza. Everybody likes pizza. So do you have that fun family night of make your own pizza?
Yeah, no, we absolutely do.
Okay. So how I think about this, how I keep it straight, I like to think of it as pizza as a service. All right. Now, when we look at this, when we think about on-prem, that's your fun family night. That's making pizza at home and work with it. Now, people listening to this are going, wait a second, Matt, this breaks your cost model. This now, we do make it on pizza night. What's the major value add, the value prop when you do make it on pizza night?
Well, you get to pick and choose how you want your pizza to be.
Pick and choose, and it's quote unquote less expensive, right?
Yes.
All right. Now, what I'll tell you, especially with 5 kids, it's a concern for you. But Garrett, now, next time your beautiful bride comes along and says, "I want to do make it on pizza night," I got a solution for you. All right. So when we think about this, yes, the ingredients will cost less. Your pizza, your dough, your tomato sauce, whatever toppings that you have will cost less. They're not going to be the same quality as restaurant quality, or even if you have take and bake pizzas or even delivery, they're not going to be the same quality. But also, what goes into make it on pizza night? You have to turn on an oven. You have to have an oven first off. You have to turn it on. And now there's like these new ovens that are out there that are just designed to make pizza. I have to go get them because they can make a pizza in a minute. I'm like, oh, I'm in when it's there. But also, who cleans up? What's the rules at your house? So who cleans up whenever you have dinner?
Well, whoever cooks doesn't do the cleaning.
Yep.
So typically my wife will cook and I end up cleaning everything afterwards.
Yep. And do you like to clean?
Not my favorite thing to do.
Not your favorite thing to do. Or the kids have to get involved with that. Have you ever had, remember Caitlin, she loves bacon. Have you ever had they took the last piece of bacon argument in your house?
Yeah, that typically happens frequently with all of them.
Emotional cost, right?
Yes.
And then when you take away electronics, that cost keeps going over the next week, right? The point is, when you look at the total cost of ownership with Make It Own Pizza, that's why we talk about this. Will it save you money? No. If you look at the whole cost of it. Saves you money on the ingredients, yeah, I'll give you that. But you have to look at the whole cost of an inside environment. And with Caitlin, when you get the last piece of bacon and she hasn't gotten it, there's a lot of arguments that happen. Pizzas get spilled, dumped, and like I said, we're all scared of it. But when you look about this, how I keep it straight. Infrastructure service, IaaS, that's take and bake. You go to your local grocery store, And in Texas, we have a thing called Pop Amerifreeze where, hey, I want this pizza. I still got to take it home and cook it. I still have to maintain it. Or I have it delivered. I just pick up the phone, call somebody, and they deliver a pizza to my house. Or I go out to eat, and I can leverage all that. Now, dining out has some costs associated with it, but which is more expensive? So the next time your beautiful bride comes to you and say, hey, I want to go out to eat, or I want to make pizza night, and you say, no, Matt said it's cheaper for us to go out to eat for pizza, and you can put all 5 kids in your van, and away you go off to eat dinner. So that's how I keep it straight. It's a fun way to think about this. I don't think, although I don't know 100% certain because I don't have preview to the exam questions, you'll be quizzed on pizzas and service. But my friends, it's a way you can keep it straight in your head. It's a way you can keep these different terms. If you've never heard them before, you're going to be tested on them. So how do we work through them? So that's pizzas as a service. With that brings us to the end of Module 1, where we talked about the different types of computing models. We talked about private versus public versus hybrid. We talked about some of those key terms, elasticity versus scalability, where remember elasticity is dynamic scalability we have in the cloud. We also talked about how to keep straight infrastructure as a service, software as a service, platform as a service, IaaS, PaaS, and SaaS, especially when we compare it to on-prem. In Module 2, we are going to cover some more technologies around all these services, and we're going to focus squarely on Azure, on how Azure is physically designed, as well as some of the services that will run on top of it. Let's get into Module 2, Azure Core Services. And when we look at this module, we're going to talk about not only the core physical components of how we build our data centers in our regions, we're then going to take a look at a lot of the products and solutions and even all the management tools we have available to work with Azure. As a good friend of mine on our team says, we're going to go an inch deep and a mile wide. And guess what on your exam, folks? You're going to have to go an inch deep and a mile wide. You'll have to know the concepts of these different technologies. You really won't have to know how to do a lot of this stuff, but you'll have to know what they are and what they look like. So when I look at the online learning course, anything that says core services is a great area to focus because you will be tested heavily in this particular module. So when we think about this, let's look at the core Azure architectural components and how do we design our data centers. It first starts off with big buckets we call geographies, and they really help us contain our different data center areas, which we call regions. And the good thing about this, we set up our geographies from a data residency, a compliance, and we try to make sure that all the applications and everything that run in those geographies are all closely related by their regions. Inside of Azure, we have Americas, Europe, Asia Pacific, Middle East, and Africa, where we store all of our regions inside of it. So we have this big geography, and this is something we design at Microsoft. You as our customers don't worry about this, but just understand that everything goes into geography. And inside the geographies, we have our regions. Our regions represent a collection of data centers, and we have regions all around the world. We have a lot in the US, we have a lot in Europe, we have them in Asia Pacific, but when we think about our regions, they're a collection of data centers. Important to note here, especially when we talk about some concepts coming up around availability zones and sets. Understand a region is a collection of data centers. On the average, talking with some of the folks in the product group, an average region will have 16 data centers. Now, folks, I want to make sure I'm very clear with this. Sometimes a data center will look like, hey, this is all the same place. Well, when you see the picture of a Northern Europe region, which we actually think it's most of the Northern region, it's going to look like one building. But in reality, they are separate facilities, and we'll talk about that in a moment. But the main point is they have separate heating, power, cooling, networking. They're a separate facility, although they may look like they're under the same roof. In reality, they're separate facilities. Why do we have regions? Gives us flexibility and scale, gives us data residency inside of our environments. They allow us to work with our deployments. They're really global services. And the good thing about regions, you can find resources that are all around the world for you to do your job. Be careful. Although this is not, not big differences, but not all regions are equal. Some of the regions have different resources, especially our newer regions. Well, from a virtual machine perspective, we'll have some of the newer hardware for those virtual machines, where some of the older regions may not have some of that new hardware.
Hey, Matt, so I understand that, hardware choices, that's one of the things that could pick this region versus that region, but as I'm thinking about architecting a solution, let's say I'm brand new to Azure and I'm watching this, what are some of the other reasons why I might select one region over the other?
Yeah, and so the first one is definitely making sure you pick a region that has all those necessary features and functions for whatever solution you're building. But the other things might be cost. If you think, for example, we talked about economies of scale. West 2 on a lot of the resources are less expensive. So I might pick a region where I'm not really concerned that it's too far apart. But we're also going to pick regions from a standpoint of what's closest to our users. The general rule of thumb with regions, you're going to pick the region that is closest to the people that are going to be using that data. And so when we look at the regions that are around the world, you're not going to be here, I don't know, in Seattle and pick a region in Africa to put your data. You're going to pick one of our West Coast regions for this. Or you're going to pick a region that might be driven by compliance. For example, we have Canadian regions that are available too, and most Canadian customers don't want to cross the Canadian-US border for some compliance issues. So they're going to use the data center that are up there and local to them. And so we're going to look at that. We're also going to look at latency. And when you look at solutions like the Olympics, they have to be able to distribute content around all the regions. The most important thing about this, you put the data in the regions that you need to choose. We don't choose them for you. You choose the regions. The geographies have some nice things for us, and we work with them. We'll talk about in a second with region pairs, because every region has a buddy. And that buddy is designed for our fault tolerance, for our disaster recovery. Something happens to a region, we can fail over to another region for it. So really, cost is going to be a concern, and then location is going to be one of those other areas that we want to work with, and then also making sure we have the right services are some of the common reasons we choose regions. And sometimes, that feature, hey, I want to use that new feature in Azure. It's not in region 1, but I got to use region 2 to get a hold of it. So there's lots of factors. It's a very easy decision to make. It's just drop down list. But now you got to make sure you pick the right one. And that's not even mentioning we have special regions we'll talk about in Module 3 for the U.S. government and for China data centers. So we have some special issues with those of how we adhere to the compliances for the China government and U.S. government as well. And we'll talk about those in Module 3. I mentioned this, every region has a pair inside of here. This is a small subset of the region list. We have lots of regions around the world, but you see some of those common pairs. The general rule of thumb is every region pair has to be at least 300 miles apart from each other. So we're talking about huge physical separation between this. This is done by design. You don't pick the region pairs. Once again, just like our geographies, at Microsoft, we design these region pairs. It's really designed in case one of our regions goes down, we can fail over capacity to this other region pair. Bear in mind, we also look at inside those regions, we have capacity. If something happens inside the region, we can fail over with inside the region before we go to the other region. We also do updates in a very controlled fashion. We do not update both pairs at the same time. We update pair, region A, get that update, and then we update region B. So we do it in a very controlled fashion. So we don't want to do this at the same time. The reason we have this is in case something happens inside the region. Now, I actually asked a product engineer, I said, what if both regions in the region pair go down? Technically possible. And the answer I thought was pretty interesting. At first it might sound flippant, but he says, Matt, if both regions go down, that means dinosaurs are roaming the earth. And understand what I just asked them. Two separate physical facilities separated by at least 300 miles that have over 600,000 computers in each of them go down at the same time. Is it possible? Yes. Is it likely? Most likely not. But if it does happen, that means there's bigger fish to fry, that something else is happening in the world that's causing that huge outage. And that would be a massive outage. Do we have regions go down? In my career, I've only seen a couple times where regions went down for periods of time. And just to be very clear, this is not acceptable. This is why we have service level agreements. We'll talk about those in Module 4, and why we make sure we help guarantee those. If those things do happen, our customers get full credits. When I've seen regions go down, I've seen customers get a full monthly credit on their bill for those outages. And the worst outage I've seen as of recent, was a 19-hour outage we had, which was a really bad outage. Now, here's a cool thing about this. Not to say that regions could be brought down for longer periods of time, but when you think about how we design the data centers, and it comes back to that dinosaurs roaming the earth, folks. Not saying the region couldn't have gone down for a longer period, but my rose-colored glasses come on for a moment. A region was down for 19 hours, but the true story was, and the true kind of information that's important, the region was back up in 19 hours. And that region in question got hit by multiple lightning strikes is what brought that region down. And it was back up in 19 hours, fully functional. So when you think about our data centers, and you think about these global companies, especially Microsoft that does this, we've been in this business for a long time and we know how to design them to be very resilient. So let's take a look at a region. It's my favorite region. It's where I'm hoping Garrett will send me one of these days. I get to go to the Dublin, Ireland. This is, although there's a lot of debate on this one, this is most of, if not all of, the Northern Europe region capacity that we have. Look how big the facility is. And if you just look at the cars that are around it, you get a general idea of these facilities. On the average, most of these facilities are 400,000 square feet in size. They have multiple power centers. They have multiple heating and cooling. They even have a lot of physical security. It might be kind of hard to see, but if you're looking at the picture, you might see the roundabout has a big cement barrier. You can't drive straight into the facility. So there's a lot of physical security here. And by the way, if you're not on the list, you don't get in the facility. I mean, even if Satya were to walk up in the data center, if he's not officially on the list, the data center techs will not let him in. Now, I'm pretty sure Satya probably gets put on the list, but he'll have to be on that list. Not saying he can't get on the list, but he'll have to be on the list before they let him in because there's so many compliances our data centers adhere to. There's a lot of internal security. So if you ever get a chance, if you're Microsoft rep ever, I invite you to go to a data center tour, go, because you'll learn about the physical side of Azure where all your stuff is. And our cloud services run in these regions. Now, if you look at this, you said, well, Matt, a region's made up of multiple data centers. It is. You actually see at the minimum at least 3 in this picture. You have on the very top of this environment, you have that big long strip of white at the top. You have the building in the middle, and then you kind of have the building that's kind of out back. If I had to guess, and I don't know for certain, but those are 3 different facilities. I even could take this a step further, and this is kind of a debated question with me and some of my teammates. If you look at the top facility, you see different towers. Now, I don't know what those are. My guess is, and because I can't zoom in enough, those might be separate electric and power and cooling. But the point I want to make is even though this looks like one facility, in reality, there are multiple data centers in this one geographic footprint. And that's how I think about it. So we're looking at a region, and we have these multiple data centers that have separate cooling, networking, and power. There's even separate physical firewalls that will separate it. And kind of a fun story, I got to tour the South Central data center, which is in Texas, and the person giving us the tour had us stop midway through the tour and had us look up. And we all look up, and there's a giant block of cement above our heads. And he's like, what is that? And we're like, I don't know, what is it? Well, that's the firewall. That if something happens on this side of the facility, we can drop that wall. It'll physically separate the 2 data centers. We design these for data resiliency in case something happens. As I was slowly stepping to the side to get underneath said block of cement, because on my brain I'm going, I hope they carried the one inside of there. So when we look at these facilities, you get an idea, and I want to make Azure real for you. And you can look at it. We have lots of videos online on our site where you can kind of see the physical design of this. For me, I'm curious about this. Is it something you'll ever go in and tour? If you get a chance, go. But folks, you have to understand where your stuff is going to be inside the facility. So we start with geographies. We have our regions. Our regions have multiple data centers, and every region has a pair. And that pair, by the way, only exists in the geography they're in. So we're not going to have a region in the US pair with a region in Europe. Those are separate geographies. They have to be inside that same geography of those region pairs to work with it. So Northern Europe pairs, I believe, to either Central Europe or Southern Europe. I can't remember the pair off the top of my head, but we designed them for resiliency, and there's tons of stuff that's inside of here. I could go on for days about the tours and my experience down in South Central. My favorite, though, out of all the stuff I'll tell you besides the firewall, in Texas during the summer, people turn on their air conditioning. There's a lot of power demands on our local power company in Texas. The local power company can actually call the data center and say, we need power, we need to take you off the grid. And the South Central data center region can completely disconnect from the local power company and run self-sufficient on just the battery backups that are inside the facility. So my friends, these things are designed to withstand a lot, and they're great environments. And South Central is one of our older data center designs. We're getting even better at this as the generations expand. So with that, why do I spend time on this? We have 2 critical components that we're going to work with in availability zones and availability sets. Now, before I dig into zones and sets, let's talk about what they're trying to do. First off, zones and sets are for at least 2 virtual machines or more. So I am squarely talking about IaaS here. I'm squarely talking about infrastructure as service. Zones and sets are only for virtual machines. You got to have at least 2 or more. Zones and sets are also mutually exclusive. You either pick a zone or a set to do what they're going to do. All right, so you got to pick them. But what do they do? Well, inside of our data centers, we have updates. We have to update our data center facilities just like everybody else. We also are running on physical hardware, which means we might have faults from occasional time. A hard drive might fail, or a rack might go down, or a network switch might go down. This is a physical computing environment, so we might have these faults. So what we have to do is work with our virtual machines. And when you think about the possibility of something happening from an update or a fault, how do you make sure your virtual servers are still available? So if we have 3 web servers that run our front end, I don't want an update to bring down all 3. It might bring down 1, so I'll lose some capacity, but I'll still have my solution being available to me. So zones and sets are designed to essentially make your applications fault tolerant and update tolerant. They're designed to make sure that those systems keep up and running if something does happen on our side. So it's our way of saying, hey, look, an update, we don't want it to impact you. Zones and sets are also free. They don't cost you anything. Now, the resources running in a zone or a set definitely cost you something, but this is the design and architectural decision. When you choose a zone or a set, it also locks you into a region for those virtual machines that are going to be in that particular zone. So when you design this and say, hey, I'm going to make an availability zone inside of South Central, guess what? You're locked into the South Central region for all those virtual machines. This also has to be done at the creation of that virtual machine. If I just created a VM, but I forgot to put it in the zone, you'll have to recreate it. Now, there are some ways you can export that VM and re-import it, but you're essentially exporting it and recreating it inside the zone, but you have to do it at creation time.
Well, and Matt, I think it's important to notice that you showed us in the Dublin slide that there are independent facilities for power, for cooling, for networking. Yep. And I think that's really important for everybody to understand is that one of the key benefits of these availability zone is if we have a power outage in this availability zone and you have your second VM in the second availability zone, then you will not go down in that scenario because you have independent power and networking there.
Exactly right, and that's an availability zone. And so that gets into how do we make our VMs be fault tolerant and update tolerant. And what you described, Garrett, was electricity went out. You just described a fault. So we're not just talking about a hard drive failing here. Now we're talking power to that facility. How do we make sure we keep things up and running for your solution? But you as a customer of Azure have to make this choice. You have to make what I want, a zone or a set. Now zones are a relatively new construct. And generally our advice is if you see an availability zone, if it's available in the region, choose that. Sets are an older construct, and they've been around forever, but how they do their job are differently. And so when we start with the zone, we're talking about, as Garrett mentioned, those 2 different regions. So if we look at if you think about that Dublin data center, we had those 3 facilities. If I have 3 web servers, what will happen is when we tell Azure to use an availability zone, under the covers, Azure will take a VM, put it in zone 1, take the other VM, put it in zone 2, and take the last VM and put it in zone 3. So that in case one of those data center facilities inside the region goes down, guess what? We still have the other 2 up and running. All right? Our solution's still available. Now, you have to start thinking about, wait a second, it's available. I lost a third of my capacity. I just lost one of my 3 web servers. And that's what will happen potentially if an update or a fault hits that zone. Well, what do you do then? Well, either just make sure those servers have enough capacity so they can run and 2 servers can run your full solution. But that's where a concept called scale sets come in. And we'll talk about that in a little bit, where we can say, hey, these are increasing. Let's add some resources and it'll take care of it for us automatically under the covers. So we have the ability to work with it. So the nice thing about zones, they provide that great isolation boundary. They give us independent power, cooling, and networking of how they become update and fault tolerant. Because guess what? We don't update all the zones at the same time. We update zone 1, then we update zone 2, then we update zone 3. And there's 3 availability zones in every region that you can choose from for your different solutions to run, but you have to make that choice. So now, bear in mind, we started with geographies, we went to regions, multiple data centers in that region is where zones live. Its counterpart are availability sets. And availability sets, I want you to go, okay, geography, region, data center, racks of computers. Although inside of our data centers, we use containers, we use physical containers, I should say. They're IT pack compute containers. But think about just multiple racks of computer. Now what happens when we get down into an availability set, we're inside of a single data center, inside of a region across multiple racks. Same concept. I put those 3 virtual machines in different what we call fault domains. You can have up to 5 fault domains inside of a availability set and up to 20 update domains inside of a availability set as well. You have the ability to separate all these. And once again, what you're telling Azure and you're telling Microsoft, look, I don't want a patch or something hardware like an electrical outage or a workload to fail or a different rack to go down. I don't want that to impact the availability of my virtual machines. And remember, you need at least 2 virtual machines to use a zone or a set. And what that does, it just distributes them. So those single points of failure, guess what? It doesn't impact the availability of whatever solution you're deploying inside of our Azure. Key notes here, locks you into a region when you choose a zone or a set. They are mutually exclusive. You can't choose a zone and a set. You got to pick one. Our general recommendation, if you have a zone, use it. It's going to give you a little bit more of a better SLA, which we'll talk about in a second. But we also look at it, fault and update tolerance. That's what we're trying to design our solution. And what level do you want to live at? What's your application compliance going to work with? All kind of determine that. You'll see sets pretty much in all of our Azure regions. You'll see zones in a lot of our newer regions inside of it. When I look at this, why do we choose a set or a zone? It's all about this. Part of it, it's about performance and resiliency. But when we look at our SLAs, our service level agreements, when you choose an availability set, you get 3.5 nines for those VMs, availability and uptime. And what does that mean? That means that that server is going to run 99.95% of the time. And in module 4, we'll make those numbers a little more real and kind of give you an idea what that means from a time perspective. If you choose a set, you get 3.5 nines. If you choose a zone, you get 4 nines. And so why do I recommend zones? You get a better SLA. You get that same resiliency. It works a little bit better for us. Now, when we think about what we're doing with a zone, you're basically saying, Microsoft, I don't want a data center to bring down my solution. If something happens, I don't want to bring down my solution. There's another way to do it. And that's when we talk about region pairs. You can deploy one VM in region A and one VM in its region pair. And guess what? You now have data center resiliency, and because they're pairs, you have update resiliency. So there's ways to design solutions to leverage the built-in architecture for Azure. With that said, most customers live in zones or sets when they're trying to design that resiliency inside of it. Now, here's a cool thing. We were the first company to do this. What if I just have one hand clapping? What if I just have a single server? I'm not going to need a buddy. It doesn't need a pair. Don't want to do anything else with it. Can I get an SLA for it? You can get a service level agreement. You can get 3 nines for a single VM, but you have to make the VM with what is called premium storage, which is performance. And by the way, if IOPS and disk performance is important to your solution, you're always going to choose premium storage. But you also choose what is called managed storage. If you choose premium and managed storage, Azure will give you 3 nines for that single VM. So you can still get an availability, you can still get an SLA for a single VM. But most times when you have a virtual machine running inside of Azure, guess what? You're going to put them in a zone or a set depending on what's available inside of your region.
Yeah, Matt, there's a lot of activity going on. I mean, one of the questions here is how important really are availability zones and availability sets? I guess probably not just from a technology perspective, but a lot of people are thinking about taking the Azure exam. So how important are these concepts to really understand?
So first off, from an exam standpoint solely, and we'll get into the real reason why we use these from a practical usage today, I will tell you folks from my personal experience, you'll see zones and sets on every exam you take from an IT infrastructure side, and then some. You'll see it on all the exams that I've taken in past to get my architecture. I took AZ 300 and 301, which are being updated and being refreshed as we work with it. I saw it on both of those exams. I saw it on our administrative exams. I saw it on our fundamentals exam, and understand the concepts. And really the difference when we look from an exam is how they ask the questions. In AZ 900 specifically, you're going to have to know what they are and some of the differences between it, but you're really not going to have to know why you would use it, or you're not going to give like a big giant scenario and which one would you pick. You're going to have just generally fairly straightforward kind of questions. But in those other exams, you're going to have to figure out the puzzle and the game that you'll play inside that question that's going to be inside of it. But you get to that really important question of, why do I do this? If you don't choose an availability set or option, you're just kind of rolling the dice, you're winging it. You're hoping that Azure will put the machines so an update doesn't impact those multiple virtual machines. You're hoping that it does do it, and chances are Azure won't. Most likely, if you don't choose a zone or a set, Azure will have a tendency, not all the time, but when we think about the concept of geographies, regions, data centers, racks, it can put all three VMs on a single rack of computers inside of a data center. Well, what if that rack goes down? You've lost all your virtual machines at the same time. And the cool thing about this, since they don't cost anything, it's really just a design decision. You still have to pay for those three virtual machines, but you want to tell Azure how you want to distribute those VMs inside of our physical data center. Remember, everything that we create here ends up in the data center at a physical level, and all we're telling you is how we want to do this. And since they don't cost anything, it's now about making sure that they're update and fault tolerant. Now, a great thing about this, especially before we offered the single VM SLA, when updates were going to impact where my VMs were running for my test environment, I would get an email from Azure to my global administrative email account saying, hey, we're going to have an update. This may impact that. If you don't choose an availability set or a zone, you're going to get that same heads up saying, hey, we're going to have an update. It may impact your solution that's running because you haven't chosen to do this.
And just one more clarification point that was being asked. You mentioned that we have to select the zone or the set at the time of VM creation. And I think if I heard you correctly, what you're saying is that's because otherwise Azure will just randomly place your virtual machine, and it could end up on the exact same set of hardware.
Yeah, exactly right. When and you hit the nail on the head, is that understand that when we make a VM, Azure under the covers will allocate hardware for that VM to run, and we'll talk more about that in just a few minutes. We're going to step through the creation of VM. What's that hardware look like? That's the ultimate answer in every IT. It depends. How much do you want to pay for? How many CPUs and things like that? But Azure has to allocate it physically, and all we're doing with zones and sets is telling you where to allocate it. You're getting the same allocation, but they have to be in that same region for that to occur, and more importantly, it has to be done at creation because we have to allocate that. You can move the VMs, and there's actually a really good article that talks about, and I was so excited when I saw the article. I'm like, how to move a VM after creation to a zone or a set. I'm like, oh, we finally figured it out. When you read the article, it's you're exporting the VM, creating a new one, and importing that VM to that new creation. And so you still have to recreate. That's really good, especially if you already have VMs that are mature, they're running for a period of time, and you don't want to have to recreate the whole wheel. But folks, if you just make your life easy, at creation, whatever you choose, zone or set. And the other thing that we'll see is, oh, why? I know I created an availability zone. Why am I not seeing during my VM creation? 9 times out of 10, it's because you've chosen a different region. So when customers see this for the first time, they go, wait, I know I created it. I can see it in my resource group. It's there. Wait a second, why can't I pick it? You've put that VM in a different region. It has to be in the same region. So Garrett, let me ask you a question. When you think about Azure, what do you think the very first thing you're going to create? Storage, a virtual network, a virtual machine, maybe an app service? What are you going to create first?
I probably would create a virtual machine first.
Nope, you actually create a resource group first. So when you look at I trick him. It's kind of like whenever I talk to my friends, like, how do you say Louisville, Louisville, Louisville? Well, how do you say the capital of Kentucky? Lexington. Anyway, work with me here. These are things that we have. When we look at resource groups, they're the they're the easiest thing to create. There's actually just metadata. It's a container that contains all of our resources inside of Azure. So before you create anything, you'll create a resource group. Now, when we create a virtual machine here in just a minute, it's going to ask what resource group you want to put it in, or you can create a new one during that. But the very first thing Azure will do under the covers is create that resource group, which is just a bucket. Those resource groups are used to help us have the same lifecycle for an application. They're a single management unit for all the different servers. So we might have a resource group for our web front ends, a resource group for our database back ends. It really depends on how you want to organize your resources. But a resource has to exist in one and only one resource group. Now, that doesn't mean resource groups can't talk to each other. They talk to each other often, and we'd be able to leverage the resources in different resource groups. So we use it for simply organizational purposes of our resources. And why and how, it's really up to you. How do you want to set them up? We also set security in our resource group with what is called role-based access control. We'll talk all about that in Module 3, but it's how we secure our environments. Resource groups can contain resources from multiple regions, so you're not locked into a region. When you create a resource group, you pick a region for the metadata for that resource group to live, but resources can be from multiple regions of different types of resources. So you don't have to have just all VMs in a resource group. You can have the VM, the network, the storage, whatever you want to put inside of a resource group, and they can be anywhere. Now, 9 times out of 10 with most customers, when they create a resource group, all the resources in that resource group will live in the same region. That's often just a general design principle. Now, the last thing, and it's the last bullet on this slide, and it's very, very important. We don't back up your resource groups on your behalf. If you think about all of our customers, we just don't have capacity to back them up. The reason I mention this is if you delete a resource group, you delete all the resources in that group. So if I were to go delete a resource group, it deletes everything inside of it. So how do I back it up? How do you back up your data today? Make sure you have your backups and your templates and whatever you need exported inside of it. In Module 3, we're going to talk about a fantastic concept called a lock, which prevents accidental deletion of resource groups. And it's important to do that because you want to protect your resources, because once that resource group is gone, it is gone. So be aware of what we want to do with our resource groups and treat them very carefully. They're containers. Now, for what Garrett and I do in our jobs, resource groups are great. Whenever I deliver a class like I'm doing here, when I'm done with the class, guess what? I go in and I delete the resource group so I can stop the consumption of my resources. That makes it very easy for me to manage my Azure subscription that I work inside of it. So resource groups will be the very first thing you create. They're for organizational purposes only. And that's all. They can have whatever you want inside of it after that. All bets are off after that. Now, I mentioned a key term, and it comes into the hierarchy of when you think about how our structure of our Azure environment is created, we have a very specific hierarchy. At the very top, we have this concept called management groups. Under the management groups, we actually have what are called subscriptions inside of Azure. And subscriptions are where you create resources. Now, in Module 3, we're going to talk about another term, and I want to just bring it up right now. We have subscriptions is where you create your resources. And if you look at the slide, you go subscriptions to resource groups to resources, right? That's how we flow down. But there's another term you'll hear inside of Azure. It's called a tenant. And tenant and subscriptions get used interchangeably all the time. Folks, they are very different terms. Where I want to keep your brain at tenant, when you hear the word tenant, think that's where my Azure Active Directory lives, because that's where it does live. It's what you authenticate against. Remember, I can't do anything inside of Azure until I first log on. And in Module 3, we'll talk about Azure Active Directory, and we'll talk briefly about the tenant. But you log on to the tenant to gain access to your subscriptions. And we'll talk more about that in Module 3, but it's important you understand we have to log on somewhere. You're going to be logging on against the tenant. And that's one of the things the tenant does. There's a few more things, but at a high level, that's what you need to keep it straight. So we have management groups, subscriptions, resource groups, resources. And why do we have these? Because we can do things like policy at different levels. We can set security at different levels of how we work with this. It's how we organize and work with our resources. And depending on what level you want to work at, what scope you're working at, you have the ability to do that work and control how people work inside of Azure. We're going to talk a lot in Module 3 where policy comes in, role-based access control comes in from a security standpoint, lots of reasons why this hierarchy is important, and lots of reasons why you need to keep the term subscription and tenant different. And my kind of my pet peeve, if somebody comes up and he says, Matt, I'm going to create something inside of my Azure tenant, my polite remark will be back, you're not creating a tenant, you're creating a subscription is where you create your resources inside of there. So when we look at core services and products, let's take a look at how we can actually create a virtual machine inside of Azure. So I'm going to take you through the creation of a virtual machine from the beginning to the end. And the cool thing about this virtual machine, you'll see how easy it is to create a resource, but you'll see all the resources that are created. So let me hop into my portal here so I can actually show you what Azure looks like. So here is my Azure portal. You see my environment ready for me to go. Couple quick things that you want to tour around inside the portal. First off, over here on the left-hand side, you have your management bar. Now, by default, and this is actually a debate question inside of Microsoft, this is how I learned how to use Azure, but a lot of my teammates do not use this. It's a docked flyout menu. I can minimize it this way, so I just have to remember the icons for screen real estate, or I can bring it out so I can work with the resources. Now, I do like to show this just from a standpoint, if I go to all services here, notice I have different services I can bring in. If I highlight app services, I have this little star that's available for me to fill in. And if I mark that, I mark it as a favorite. Folks, when you first come into Azure, I'll tell you that I don't know if we do this on purpose, but we try to confuse you. We put all this stuff in there. And we're just trying to show you the highlights. And by the way, the default favorites are the most popular things that people use in Azure. Chances are, when you think about the hundreds and hundreds and thousands of services that are here, guess what? You're only going to use a handful of them. So make them your favorites. Don't have this big, long menu structure you have, and you can organize it inside of it. So use those favorites to add and remove the services that are important to you and what you do inside of Azure. Azure should be easy for what you do inside of it, because you're not going to use all the services and features of Azure. You're going to use a certain subset for whatever your job is inside your organization. So you want to have that set up. Now, the other cool thing about this, notice that I'm on the resources for this, and I'm going to click on the star in a moment, but I always like to point this out. Inside of Azure, we want to make it easy for you to learn how to do these things. And you notice that I'm in app services. By the way, the app services is the main model we use to write applications natively against Azure. So we're talking about platform as a service, PaaS here. But look at below the description of what the service is, there's some free training. So we actually give you links to outside of Azure articles to help you learn about this particular app service. So we want you to learn these things, and we want you to be curious about these things. And if you're like me, that's how I learn. All right, so I'm just going to click on the star, and notice what happens. It puts app services at the bottom of my list over here on the left-hand side of the screen. I can drag that up if I want to. And if I don't want my favorites anymore, I simply move over it and I clear the star. So navigating this portal is important. And notice where I'm at here, folks. I'm at portal.azure.com of where I'm at. This is called the management portal. We'll talk about some of the other tools in just a little while of how we can work with and manage Azure. I'm just showing you one way to get things done. There's actually, like most of the products we create at Microsoft, lots of ways to whatever you want to work with, whatever your personal preference. I don't want to use the portal. I want to use script. Okay, we have a solution for that. Or I want to use an app. We have a solution for that. We'll talk about those in a little bit. Another little quick tour here. If you don't like the menu on the right side, you do have the ability, if I look at the little cogwheel here and go into settings, I can have that menu docked or flyed out. And if I choose fly out, all it does, it puts it up here in the left, where I can simply click on it to get the same menu. So it just kind of hides it. Once again, people do that for screen real estate to work inside of it. You can change the colors. We have high contrast for some accessibility needs inside of the portal. So we have the ability to work with it, including language and region. Now, the other thing that I like about this, and the last thing I'm going to talk about right now, and then I'll hop in to create a virtual machine, is this screen at the top and this very important thing that says search. And let me just kind of minimize that out of the way. This is huge, folks. When we look at this, if I just start typing in availability, okay, notice what happens. It starts coming in some of the services I have in Azure, but more importantly, over here on the right, it gives you some of the information in the Microsoft Docs. And I click on what are availability zones. It actually takes me an article on our doc website that explains what zones are, what zone services, how they work, what services actually use the zones. We have the ability to work with this. And notice, there's no additional cost for virtual machines running in a zone, but you get a 4.9 availability, all right? The cool thing about this, all I did was a search. All I went up the bar and said, this is what I look for. Folks, Azure should be easy to find things inside of it. This is how you find things. You simply run a search inside of it, and then it has the added bonus of giving you a search engine that'll query outside articles. Now, not on AZ900. But when you take other Microsoft exams, we have what are called performance-based testing, aka you're going to have labs. In other words, our newer exams, you're going to be asked to go do something. Oh, you got to go create a virtual network, or you got to create a storage account, or you got to create a virtual machine, and they'll give you all the parameters, but you have to make them. In other words, you have to know how to use this portal, or it'll say, hey, this resource is broken. What do I do when I take these exams? I just run the search. Now, in case you're wondering, now I didn't do this, only somebody told me this. When you run that search, it will give you the links to the outside articles, but when you click on them, this is what somebody told me, I would have never done this, never, nope, not me ever. It comes up to the link does not work. It will not let you go look. In other words, our exams are not open book, definitively not open book, but you can use the search bar to navigate around those exams very quickly when you're trying to create a certain resource or move around to finding a navigate a resource to whatever that task or question they're asking you for. So exam tip, learn to use this search bar. Real life world tip, learn to use this search bar. It is important to how to move around the portal inside of it. So let's go ahead and get into the story of how I actually create a virtual machine. So I'm going to go, and this is just one way we can do this. I'm going to go to all services. Or actually, I'm going to go to create a resource, I should say. And create a resource, I'm going to go to Windows Server Data Center. I'm just going to go ahead and click on that. Make a Windows server, and now it takes me into the wizard to actually step through this. Now, folks, the first time you create anything inside of Azure, I recommend that you use the GUI to create it. So you can see all the wonderful parameters, all the things that go into creating a virtual machine. Down the road in real life, folks, you're going to learn how to script and automate this. And I'm going to talk about some of those tools and techniques in a little while when we get into the management of Azure, but you're going to want to learn how to automate this. But for us right now, we're just going to step through the GUI so I can show you all the stuff that's being created for it. So it says basic, what subscription, and notice the very first question here, what resource group? I have a resource group already created called AZ Fun for our fun that we're going to have today. I'm going to give it a name. We'll just call this Fun VM. This, by the way, the worst part of my day is typing things in public. I'm going to say Fun VM2 because I already have another VM created. I can choose what region I want to put this virtual machine. I'll choose West 2. And notice it comes up, it says availability options. And if I click on the down arrow, notice I have the ability to choose a zone or a set. And I have this option called preview. Now, I'll remind you again in Module 4, but at Microsoft, the life cycle of all our products go through 3 really big general stages. We have a private preview, and that's where we're generally looking for a certain type of customer that's going to do a certain type of thing, and they're invited for a private preview to work with those to actually work with our product group to develop a solution. After it graduates from private preview, it becomes what is known as a public preview. And in Azure, we show you those. You're seeing one right now with virtual machine scale set with preview in parentheses. What that is, it's a public preview product. Now, the only thing I want to be very clear on, friends don't let friends put production stuff in preview. Why? Because there's no guarantee that a preview product will graduate to its next step, which is called general availability. Now, most products that hit public preview will become general availability. But understand, while it's in preview, generally there's really not a lot of cost associated with it. There is some, but there also is no service level agreement. We give you no guarantee that they're going to run. It doesn't get its official cost or service level agreement until it hits general availability inside of here. But notice I have availability zones. I have the one in preview and sets, but I'm going to just make a quick change. Instead of West 2, I'm going to choose South Central. And notice now, when I highlight this, notice what's not available for me, availability zones. Remember, not all regions are created equal. South Central is one of our older data centers. Now, I don't know if South Central will ever get availability zones, but right now it doesn't have the ability to have availability zones inside of it. And if I want to choose an availability set, because I'm going to put it in South Central, it's going to ask, what set do you want? Now remember, what if I already created a set? So Garrett, if I know I created a set, why am I not seeing it here? What would be one of the first things we could check?
Very likely because you put that in a different region. Your availability set's in a different region than where you're trying to create the VM.
100%,
right.
Yep. Understand, folks, if you've created an availability set, and I get this question all the time, why don't I see it? I know it exists, I created it, you're probably in the wrong region, okay, that are there. So I'm going to choose an availability set. In this case, I don't have one. I kind of fibbed a little bit. I want to see if Garrett was paying attention, keeping awake over there. And I'm going to say create, and I'm just going to say fun set 1. Inside of here. Now, folks, word on my naming convention, I just kind of have fun because we're in the fun class. General rule of thumb, have a naming convention. I don't really care what you call your stuff. Just make sure it makes sense to you so you can find and work with resources. So I have an availability set. Then I have an image. And right now I'm pulling a Windows Data Center image, and this is coming from the marketplace. Understand what we're doing here. I'm buying a brand new license for Windows Server. Well, if I wanted to choose one of the other regions that are the resources that are here, if I click on this, I have Ubuntu, I have Red Hat. Wait a second, those aren't Microsoft stuff. Those are Linux machines. Azure is a heterogeneous environment. Matter of fact, Linux, from a standpoint from virtual machines, is outgrowing Windows servers currently. We have more Linux systems running, or will be running, in our environments. People like those servers, whatever they want to choose, all right? Why do we choose other systems? It solves a problem for whatever we're trying to do. Might want to save us money. You have images that you can pick and choose from. They all come from the marketplace, but the cool thing about the images, you also can upload your own image. So let's say you have an example, hey, this is what my SQL server looks like, or this is what my Apache server looks like. You can take that image and upload it into your subscription, so now you can use that image for creation of virtual machines that helps speeds up the process for you. Now for us, I'm making a brand new machine, so I'm just going to choose Windows Data Center. Then we have the size of the virtual machine that we have. And notice the size is a DS1 V2, which currently on my subscription costs $46.43 a month to run, but it's one CPU with 3.5 gigs of memory, a fairly generic server. If I click on change size, I have the ability to change the size to other VMs. Now, this is not all the VMs. When you first come into this wizard and you go to change size, it's highly filtered for the different types of generations. But let's say I want a bigger VM, I can simply choose a D2 V3, and that system's going to cost me a certain amount of money, but I can select that, and now that's going to cost me $80, but now I get 2 CPUs and I get 8 gigs of RAM. So I give myself a little more headroom. My general rule of thumb when you're choosing the size of the VM is make sure you pick a VM that you can resize. So go small, go low, all right? You can always change the size after you create the virtual machine as long as that size is available to you in the region you choose. The next thing here, it's important. This is a local administrative account. So I'm going to go ahead and type in my local administrative ID and my password. Oh, and by the way, just kind of a fun here. You can't use words like admin or administrator. For my open source folks out there, you can't use root. But if you happen to be a Marvel fan, you can use Groot. We have to have fun with this, folks. And if I type in M. Hester, I'm just going to use my alias here. And I'm going to type in my password. And trust in the fact that I'm not typing dots, I just typed in the word password inside of here. Notice, and in case you don't believe me, if I hover over top of that and click on it, I've typed in password, it doesn't let me use those words. So you have to come up with a complex password of numbers and numerics that we have. Whoops. I'm going to hide, there we go. And then you have to repeat it in case you just forgot it 2 seconds ago. So I'm going to repeat it in. Oops, I knew I got that wrong. Worst part of my day right now is typing passwords. All right, got it matching. Then we have this thing called an inbound port rule. What this is allowing us to do is open up port 3389 for RDP management. So I can log into this VM and do work on it. Remember, this is a virtual machine, it's a server, there's nothing there. But if I want to install and configure it, update it, this is where I would come into that. We're actually modifying what's called the network security group here. We'll talk more about that in module 3, but it's important. But also, notice the warning message here. It's telling you you have a public IP address for this VM and a public port. In other words, this is potentially vulnerable. In most of your organizations, you won't be able to do this. You won't be able to open up this port, and this virtual machine won't get a public IP address. I'll talk more about that in just a little bit when we connect to the VM after we create it, but that's here. We can save money using what is called the hybrid benefit. I'll talk more about that in module 4. If I go next to the drives, just at a high level, I can choose what type of drive I have, which is a premium SSD. If I pick on the down arrow and choose standard, notice what happens. Azure come up and say, hey, look, you can do that, but this may not be as performant as you want. You want to leverage premium drives for all of your virtual systems. It's just a performance benefit. But if I just create down here and I expand the advanced, notice it says use managed drives or managed disks. What's that mean? That means Microsoft is going to manage the storage of this virtual machine under the covers for you. You don't have to worry about it. Now, you pay a little bit of upcharge for that or a little bit of a premium for that, but the cool thing about it, you don't have to manage that. And remember, we talked about sets and zones to give machines availability inside of here. If you just have a single VM, you'll use premium managed drives to get that guaranteed SLA. But if I simply say no to this, Notice what it asks me, where are you going to store it? Now, I'm responsible for the management of the drive. For us, I'm just going to choose yes, because I want to have it managed by Azure. And by the way, most customers will do this because they don't want to have to manage a story. Even though I have a set or a zone, I don't have to worry about it.
Hey, Matt,
yes.
With the managed disks, does that actually allow for a more predictive cost model? We talked about predictive cost versus variable cost. Is this, using a managed disk, does that give us a more predictive cost on the disk?
It will, because we have controlling of how much traffic is coming in and out of it. That's part of that premium managed storage. But the only thing we can't tell you for certain how much you're going to put inside the VHD, how much data is going to be there. We can give you a really predictive cost of what that service is going to cost you, but then it's how much are you storing inside of that. And hopefully you'll have a general idea. And the cool thing about this, and this is just IT 101, this is just where the OS drive runs, right? Where the actual operating systems run. In real life, and you see the options here, you're going to create and attach your drives for data drives and where you're going to put that information there. So it does help us have that predictive cost, but once again, we still don't know how much you're going to store. So we can get close, but how much is that VHD going to be? And bear in mind, this is a virtual hard drive. I believe, and I'll get this wrong, I always get it wrong, it's going to show up like you have 127 gig, but in reality, that VHD file is maybe 1 or 2 gigs in size. So you're only paying for that 1 or 2 gig, not for the actual what looks like capacity inside the virtual machine, just virtualization. Click on Next for networking. Notice inside of networking, everything has to live on a network. Now, I'm not going to do a deep dive into the virtual networks in this course. It's kind of out of the scope of what we have. But folks, I just want to point out, notice we use this, what is called CIDR addressing or CIDR addressing, depending on who you talk to. But you see that nice pretty /24, that tells us our subnet mask for our network ID and our host ID in IP4 mathematics. You won't really see this on this exam, folks, most likely, but I guarantee you'll see it on the other exams. You'll have to know what that /24 is. Now, for the folks that are going, I know IP, I can't remember. If I were to tell you that /24 means the subnet mask is 255.255.255.0, that's what it's telling us. If that makes sense to you, then you're well on your way. But we do offer some courses that help refresh modern IT essentials that are online and available to you if you want to leverage it. So I'm not going to go into a lot here. You'll also notice that inside of here I have my port for the inbound. We have load balancing. We'll talk about that in just a little bit as well. Next, if I go into management, it tells me different things I can do inside of management. Notice we have the Security Center basic plan. Every customer gets that. I think of Security Center as a way that we can advise you what's going on inside the virtual machines. We also have boot diagnostics, which is the general status of the machine. Is it restarting? Is it up and running? What's the general CPU performance? What's the general networking performance? But if you want to reach in and leverage Azure Monitoring Service, you can reach in and install an agent on this VM that will pull out, in this case, it's a Windows server. It'll pull out the event log from the Windows system so we can manage that fully. And now I get one single pane of glass that tells me, hey, this is how the machine's running in Azure, but also now under the covers, how is that machine running? And you think about kind of the problem. When I'm looking at metrics inside of Azure, it's going to say, hey, this machine's at 85% utilization. You're probably going to ask the question, why? The log files inside that VM will tell you that other part of the story. Azure will say you're 85%. Why? You'll reach into the machine and look at the log files to pull out that why inside of it. It's not turned on by default for the simple fact that it does create some additional storage. So we want to make sure customers are aware of that. And you may not need to log inside of there. It all depends how you want to work with it. We have a system managed identity here, just real brief on that. What that basically means is that this machine may need to go access resources in Azure, but it doesn't have a user ID and password. So if I give it a system managed identity, I basically give this VM a user ID so it can run around and consume resources that it may need to do its job. We have the ability to do auto shutdown on VMs. Our mom always, or at least my mom always told me, turn the lights off when you leave. One of the common methods that's happening inside of Azure is, why do I have 15 servers running over the weekend when I know 5 servers will cover it? During the week, I need all 15, but on the weekend, I only need 5. Well, we can enable what is called auto shutdown of those VMs so that every day at 5 o'clock on Friday, it turns off those VMs. Why is that important? You reduce your cost charges. I don't need them. Why leave them on? Why didn't we do this on-prem? We were afraid that the server wouldn't turn back on Monday morning. If anybody's ever done this, okay, I got to turn the server off, I got to reboot it, I hope it comes up, and you hit the power button, you're just going, please, 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 please come up. Well, guess what? Auto shutdown turns off that machine. Now, I want to be very clear here, and it's a marginal thing I just want to make sure you're aware of. Notice it says auto shutdown. There's no auto turn back on, although you can do that very easily in script to have a script turn VMs back on at Monday. It's actually a very straightforward, and within the shutdown article, I talk about how to create that script. I wish it was auto shutdown and turn back off, and so my request, if any product group people are listening to this broadcast, can we get an auto turn back on, please, feature, whatever you want to call it. I'm going to turn it off for the particular demos here. We can leverage Azure Backup if we want to back up the VM. I'm not going to do that for this particular instance. If I go to advanced, it tells me what extensions do I want to install here. Extensions add things. Bear in mind, what is this wizard doing? This wizard is installing a brand new virtual machine. Well, what's in the virtual machine? Nothing, just the OS, that's it. So it's a single hand clapping doing nothing. Yeah, exactly right. This is where we can come in and configure it. Now, if I choose the extension to install, just want to give you a quick little tour here. We have all kinds of extensions we can add to this. We can add in our backup. We have Microsoft anti-malware, but we have a really pretty one here. It's my favorite one. The reason I come into here, custom script extension. What does that mean? Not only will I build this virtual machine, now I can tell Azure, run a script when you're done. In other words, turn the machine on, create the Windows server, now run this script to go do something. That might be to configure it, that might be to work with that environment. It all depends on what we want to do, but we have the ability to add these custom scripts after the fact. Very common that we do this. Very common that we work with it. So I'm not going to choose any extensions here. Just close that down. Tags. Tags are a huge governance control that we have inside of Azure. We'll talk more about these in Module 3, but one of the common reasons we're going to tag resources is for the simple fact that we want to make sure a resource is properly billed. So if you have multiple departments, how do I know the finance department? Well, that VM's around the finance department. I can use a simple tag to do that to help work with the bill. We'll talk more about that in Module 3. And the last one I'm going to hop into is next review and create. Now, if you're like me when it comes to technology, like just click on the things, okay, just hit create, you're going to miss something just wonderfully important here. On this screen, at the very bottom, to the far right of the word create, it says download a template for automation. You might be impressed to know that, guess what? As I was going through this wizard, Azure was remembering everything that I was making a choice of. And it was storing it in a template file, and it's a JSON template file that I can use and I can save to recreate this VM down the road. And all the template will do is remove all the uniqueness, my name of the computer, all the IP address. It just makes it unique. So I'm just going to say download a template because I want you to look at this file for just a moment. And this template file basically has all the parameters that describe that particular VM. And if I go into parameters, you can see the different choices under the covers that are here. If I scroll through this list, notice I have South Central US, I have the name of the VM, I have that RDP port opened up, I have the different environments that are there. I even have my storage type, I have my username, all that stuff is being captured for me. I can take this template and I can add it to my library inside of my subscription, which means now I can pull this back out, dust it off, and deploy another solution. Now, I will tell you quite frankly, folks, this particular template is bigger than it probably needs to be. Most templates that you create inside of Azure are very singular focus. This template's going to create the virtual machine. This template will create the network. This template will create the network security group. They will generally be that way. This is a really big template because it has everything. Virtual machine, storage, networking, public IP address, network security group, any management extensions, blah, 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 blah. It's all inside of here, but we can capture that. Now for us, I'm just going to go back to the create a virtual machine inside of here. And if I scroll down, you'll notice that, hey, you've opened this up, you open up RDP, once again, giving us a recommendation. You're doing something that could possibly create a vulnerability. Tells us all the information about what we're going to create here. And I'm going to simply go ahead and go create. And Azure is going to go run and create this virtual machine. And this virtual machine will be up and running in anywhere between 1 to 2 minutes, depending on what you're doing inside that virtual machine. Now, under the covers, it leverages a thing called the Azure Resource Manager for the actual creation of the virtual machine. You can see the resources are already being populated inside of here. The actual creation, notice that, hey, look at all the stuff it created, all the resources. It's creating the availability set, it created the IP, it created the network security group, it created the virtual network interface, and we're going to see this, and as I refresh this deployment, we can see different information that's there for us to use and leverage, and it'll take another minute or two. It'll create the VM. We'll just take a quick look at where that VM is created. And then we'll move on with the rest of our presentation. So we'll give it a second to run here. But Garrett, when you think about this, what are some things that kind of strike you as I went through that wizard? What are some things that you were kind of interested in, or kind of some areas you may want to dig into a little bit?
When I'm thinking about how you're building this, I'm thinking about reusability, right? As an admin, if I'm going to have to stand up a large deployment, I don't want to have to go through this wizard every single time just to create another virtual machine. So I really like the fact that at the end of all of it, you're able to download that file and create that repeatable process in a much simpler fashion.
Yeah, and I'll do you one even better. At the end of the module, we're going to talk about other ways. I could have done this all in Azure PowerShell. We also have a thing called the command line interface, CLI for short. I can automate all of this in lots of different ways. And so, people sometimes joke at us, Microsoft, well, we have 8 ways to create the same thing. We do, because we want to give you the flexibility, what's the most point. But you bring up a huge word there, repeatability. We want to make sure that we can duplicate this in a very consistent, controlled fashion. And when we start talking about deploying things, templates are one way to do this. I talked about another one. Well, I want to have a server, and this is always going to be what my web server looks like. It's going to have this server, it's going to have Apache, it's going to have this certain configuration. This is where it's going to pull its images file directory from, and I have all that stuff. Well, I could actually just create that as one of the images. So I can, hey, my starting point is just not the OS. My starting point is everything installed and configured, just deploy it. And then I can use a template to call on that, or I can use it via script. And really, it's up to you to actually work with this inside of Azure. Now, while I was talking, it's kind of my stall tactic 101, the VM was all created for me to look at. Let me just go ahead and hop into the resource here. There's a button that says go to resource. And in the resource, I can find information about its public and private IP addresses that were assigned during creation of it. I can also connect to this. We have the RDP opened up. I'm not going to connect to it in this particular one, but we can connect to it. We also have a new one called Bastion, because the question is wait a second, Matt, I have to go in to control it, but Azure's saying that if I open up port 3389, it's a security vulnerability. And they're right. But we actually have a new service in Azure called the Bastion service, where I can actually put this virtual machine with no public address behind a separate network that does have a public IP that I have to authenticate against first before I can access that VM. And it becomes a really nice way to connect in a safe and secure. Kind of a little out of scope what you might see on the exam, but from a usability standpoint, remember, what was my one thing? I wanted everybody to learn at least one thing during this class. Understand the Bastion service will eliminate the need to have that public RDP port and public IP. And more to the point, folks, chances are in your organizations, you won't be able to distribute public IPs onto VMs. You'll have IT governance that prevents that. Why? Because you don't want your organization to have a security vulnerability. And you also don't access a VM directly. And we'll talk about a couple other ways inside of it. So if I go back in and take a look at the environments here, just a couple highlights. I can connect, but I can always change the size. If I change the size, remember we talked about scalability in the cloud. Inside of here, I can change the size of this VM anytime I want. I can scale it up or I can scale it down by simply picking the new size of whatever I want to choose and clicking resize. Now, just a word of caution here. When you click on resize, there is a period of downtime that occurs because we have to reallocate new hardware. We have to move this VM to new hardware. The cool thing about that downtime is fairly minimal. When I say minimal, think seconds, because we actually have to move this file to a brand new set of hardware and redeploy it. Now, from my personal experience, if you stay inside the same family like the D series, 10, 15 seconds. If you go to a whole new family, like go to a G series VM, it might take a little bit longer, so we have to go dig up that hardware inside the region that you're in, but always think small. But this is a manual process when you're scaling up or scaling down. Remember what that is? Adding resources to that virtual machine for us to use and leverage inside of here. So just a quick tour of the VM, but it's there, it exists, and it's available for us to do to whatever workload that we want to use and leverage. What are some other virtual machine services we have inside of Module 2? So understand we have Azure VMs, creating the virtual machine that's inside there. We have a concept called scale sets. Inside of Azure, we have this concept called an auto scale set. What this allows me to do is take an Azure virtual machine and say, hey, I need to add 500 more virtual machines to solve a problem. Maybe you got mentioned on a popular show, your website's going to get popular and need more virtual machines. And the scale sets, based on thresholds, will scale out automatically, whether it's a CPU or a memory threshold. The cool thing about scale sets is that they are elastic, which means not only will we scale out, but as those thresholds are unmet, we'll start to scale in automatically for you. We also have two other ones, app services and functions. Wait a second, virtual machine services? Matt, those are platform as a service. And yeah, exactly right. App services and functions are very much platform as a service. But what did I tell you about Azure? Everything runs on something under the covers. Now, who manages the virtual machines for those app services or functions? We do. You're in the PaaS side of the house. That's part of our responsibility. You don't have to worry about patching the OS, but know that when you create an app service, you write code natively against Azure, or you create a function, which we'll talk more about those in just a little bit. Under the covers, there's an operating system there, and there's something that's running to support that app and to support that function. Inside of Azure, they're all there for us automatically. So you can't just think, when you think virtual machine, yeah, if you're thinking Azure VMs, that's definitely infrastructure as a service. But when you think app services, that's platform as a service. They all use virtual machines under the covers. Now, other common technique that we have inside of Azure that we're leveraging is actually an industry environment we have, which is called containers. And containers are different than virtual machines. VMs, when we look at them and we look at virtual machines, some people call them bloated, or I call them heavy. And what they are is, whenever you have a virtual machine, you have your common OS, you have the runtime, your whatever operational framework, and the application running on top of it. But if something happens to the application, generally you have to reboot the entire operating system to get the application to restart in a proper fashion. And pretty much with virtual machines, you rinse and repeat that. You have the same operating system, it has the same runtime, and you have the application on top of it. More importantly, you have the same OS. So they're very large files, they're heavy, they're not very portable, they're not very cross-platform friendly. In other words, hey, this OS is Windows or this OS is Linux, how do I work with it? Well, along came a concept called container, and I believe Docker was the first one to do this, and mostly for the open source. If you think about open source systems, and you think about the different varieties and distributions of Linux, there was a problem here with folks that were developing Linux. And when I mean problem, just understand there's a logistics issue here. Well, what distribution of Linux did you use to deploy that? So along came this container technology that sits on top of a common OS that gives me a container runtime. In other words, I don't care what your OS is. I'm going to give you a container runtime that we all can adhere to, and I can write my applications on top of it. The cool thing about this, it gets rid of that need of the operating system to run over applications. Because it's one of the age-old things. A good friend of mine, Bill, who I used to work with a long time ago, I used to joke with him, because Bill was a developer, very good developer. Actually great, I would probably say. But whenever Bill would come into my room and I'm talking about infrastructure stuff, I'd always joke with Bill. I said, you know, Bill, without my server, you have no place to run your application. And to which Bill would reply, without my application, you have no reason to run your server. And so we talk about the chicken versus the egg, what comes first. And what this makes this nice, it makes applications very efficient, makes them cross-platform friendly, makes them very portable, makes them movable. Now, if your brain, when you hear the word container, is thinking about a cargo shipping container in the ocean somewhere coming up the port with all the containers, your brain is in the right place, because that's what they're designed to be. Because I don't care what ship that container is. The same thing with our containers in our applications. I don't care. As long as I have that platform, I can move that container to wherever I want. As long as that common platform is there for me, I can run it. Containers become a very fast and efficient way to run code. And you think about that first scenario. If I have to reboot the application, I just have to reboot the app. Very fast and efficient, where you have to reboot the OS, then reboot the app. This is why we're using containers. You know, I always joke with some of the folks in the product group, if we did not have Azure or cloud technologies in our world today, you would all be moving from your Hyper-V or VMware farms into container technology. You'd be doing this on-prem, and it's happening now. The cool thing about Azure is it supports container technology, so we can run this application portability. Now, another fun question, if you ever meet Microsoft folks in these teams, you can kind of ask this question. I call it a debate generating question. Hey, I'll never use containers. I can just use the platform services and write natively. There are benefits to writing containers inside of Azure versus using platform as a service, but it really depends on what that application is going to do and which choice you make, because we do support both containers inside of Azure as well as the Kubernetes services. So container instances inside of Azure is basically a PaaS offering that allows you to upload your containers and work with them inside the Azure platform. So we can put these systems inside of our container service. So our container runtime essentially is Azure container instances under the covers. But then we have a thing called Kubernetes. Now, you think about our containers. We have all these little boxes of containers on that cargo ship. Well, what's the thing that moves them around? It's a big crane, right, that sits on the dock and moves them around inside of it. And who's controlling the crane? Most likely the captain of the ship is saying, hey, put this container here, and they're balancing the workloads. If you've ever watched the show Deadliest Catch on TV, they're trying to organize those containers and the crab cages to organize it. There has to be done in a very logistical fashion, kind of the same thing with our cargo ships. That's what the Kubernetes service does. It's that orchestration for managing those containers. Now, fun geek tip I learned from my friend Chris Henley. Kubernetes in Greek, you know what it stands for in Greek, Garrett?
Yeah, I have no idea, Matt.
It stands for captain in Greek. Loosely translated, by the way, loosely translated from Greek, but Kubernetes stands for captain. If you think about this, and for your exams, keep it straight. The captain of the ship is Kubernetes. It's the orchestrator. What is it orchestrating? The containers for those application codes inside of it. So Kubernetes, Greek for the word captain. Learn something new every day. Some more services we have. We have Azure Network Services. We have the ability inside of Azure to create virtual networks. We did that when we created our virtual machine, and that virtual network is where everything lives. Everything has to have an IP address for communication. We have load balancers. Load balancers are great because that's where your public IPs are going to go. If you have a web farm with 3 servers, when somebody comes to your website, how do you determine which server they go to? Well, what if they all flood number one? Number one's going to get overutilized, and the other 2 are not going to have any work. A load balancer balances the load of that workload coming in from the internet to those different VMs. We also have VPN gateway and peering, and I'm going to talk about those in a moment, but it's one of the key technologies we use under the covers on how we can connect our virtual networks, but also more importantly, how we can connect from on-prem into Azure for hybrid networking. So we're going to use VPN gateways or peering. I'm going to talk about those differences in just a moment. We also have Azure Application Gateway. Well, what about our applications behind the environment where we don't necessarily need a load balancer for those virtual machines? We have app services, and we want to make sure we balance those load. That's where the gateway comes in. The gateway also has a huge security advantage for what is called a firewall, layer 7 firewall security. And what that is, whenever we have data coming into the application, we just let you come in. Hey, your port 443 coming in. Well, what happens is that the application gateway will inspect the traffic to make sure that information is valid traffic and not contain bad packets. Content delivery network. I've mentioned this a couple times, but I'll mention it again. It's how we move large amounts of content in Azure from one region to other Azure regions around the globe. The best case study we have here is the Olympics. The Olympics in Rio actually leverage the content delivery network, and I believe they're going to leverage it for future Olympics. But what happens is when you record an image over here on one side, how do I get that file over to your region that's closest to you as a consumer so you can watch an Olympic event? You know, I oftentimes like the field and track events. They're not always on TV when I can watch them. Well, I can just go to the website, download it. It's coming from a content delivery network. It moves content on our networks, on our background. It leverages it. And a lot of services inside of Azure, for example, the front door service uses the content delivery network when people come into our front door without letting them inside of it. So when we talk about network and connectivity options to Azure, this is where we have to talk about a couple things that are important to our networking story. First one is peering. What is peering? Peering is connecting virtual networks together inside of Azure. And so if I have VNet 1 over here and VNet 2 over here, by default, virtual networks are isolation boundaries. They don't talk to each other. So if that's what you want, you never do anything with them. They're ready to go, and you put all the resources in the different networks. But what if I want VNet 1 to talk to VNet 2? I create what is called a peer relationship. Now bear in mind, this is on our network, so this is in our private network, and that peer, all it does is creates a pathway for Azure to be able to talk VNet 1 to VNet 2. It just creates a roadway. Azure under the covers automatically makes the routing table so this occurs fairly easily, and it takes just minutes to set up a peer. Peering, though, does not encrypt traffic between virtual networks. So inside of Azure, we can set up a VPN VNet connection, which will set these 2 networks up, and then we'll encrypt the traffic inside of it. Now, folks, once again, remember, where are you at? You're inside of Azure. You're already on a private and safe and secure network. Unless you have an application that needs an additional layer of security, you're not going to use VPN gateways. You don't need an additional layer. Now, some customers that might be in some of the governmental data centers may need that for compliancy, but most customers do not. In other words, use peering unless you absolutely need that encryption channel. One, it's easier to set up, it's fast, it's very efficient. But now let's talk about our on-prem environments for a moment. How do I connect my on-prem systems to Azure? And there's 3 really big ways we can do this. One's called a point to site. And I want you to think as an administrator of the environment. I have something on my laptop, and I want my laptop to connect to a virtual network inside of our cloud. I'll use what is called a point to site connection option. In other words, I load essentially a little VPN client on my laptop that I can log on to that VPN client and connect to that virtual network and do whatever I want inside that virtual network. It's a point, administrative point into an Azure virtual network. Now, if you want to connect your business inside of Azure, what you do is called a site-to-site VPN connection. And what this does, every business, you have a public internet-facing router. It sits on the edge of your network. It's how your business can talk to the web and talk to other resources around the world. What you do is at that level, you can configure that router to talk to an Azure virtual network. And what's nice now, you've basically made Azure a branch office of your environment. You've connected these two networks together, and whatever resources I have on-prem here can then talk to the corresponding Azure resources in the cloud just by going over the site-to-site connection. Now, both point-to-site and site-to-site connections run over the public internet. They're VPNs, so that traffic is encrypted from our points to the actual Azure networks that we have inside of there. But they are going over the public internet. Now, with site-to-site and point-to-site, the default traffic speed is 100 megabits a second. And with point-to-site, that's the fastest you can go. Now, it doesn't seem like a lot. In reality, it's not. But when you think about we're just doing RDP and maintenance, it's actually quite a bit of traffic. With site-to-site, you can actually go up to 1 gig. You can actually purchase different SKUs to increase the bandwidth inside of there. But if you don't want to go over the public internet, how can you access Azure? We have a concept called ExpressRoute. An ExpressRoute is a private, dedicated connection that you have on-prem that will connect you directly into Azure so you can access our resources in our data centers. And by the way, it's not just Azure. We're thinking of the Azure world, but once you have an ExpressRoute connection for your business, you could possibly leverage other services in our Microsoft cloud environments. Things like Dynamics 365 or Office 365 are available for us. That private connection is a dedicated line. Now, folks, ExpressRoute can be expensive and can be cost prohibitive. There is a price that you have to pay for that, and you can go anywhere between 1 gig connection up to 10 gigs. You can have it metered or unmetered. And if you look at the calculator, if you're doing an unmetered connection on our premium switch, it's approximately $50,000 a month for that connection speed. Now, it seems like a lot, but depending on your business, that might be a drop in the bucket to what you need to do. Why we have ExpressRoute connections is when you need that high-speed dedicated channel into Azure, so we have that constant communication, but it's a private network. Now, you also have one other potential charge here. You have to have an MPLS circuit. In other words, you have to have a provider that drops that fiber into your business. They're going to charge you generally a monthly fee for that fiber plus installation and configuration. It's almost like when you buy a brand new house and you get internet access for your home, you have to drop that information inside of it and hope they have fiber or something into your environment to work with it. So we have ExpressRoute connections, which gives private connections into Azure. So we have lots of connectivity options for us to use and leverage on how we connect at a real high level. Now, folks, I just got done talking about networking, and just a little bit before moving to data, networking in a lot of our courses is usually one day all by itself. We spend 8 hours just talking about networking. So I'm just giving you the tip of the iceberg, like we're going to talk about data here. When we talk about data, we have 3 main types of data. We have structured data, we have semi-structured data, and we have unstructured data. The most popular on this list, by the way, is unstructured data. Inside of Azure, we call unstructured data called blob data or binary large object. Now, I'm actually rather disappointed when I learned that blob was an acronym, because in my brain, I'm going to the 1970 horrors movie with the green blob running around trying to catch people. But it really is just unstructured data. Most of the files we work with, JPEGs, videos, PDFs, Word documents, Excel spreadsheets, email, Visio diagrams, pretty much anything we put in SharePoint, unstructured data. But how do we use that? Well, I'm going to talk about how we leverage it inside of Azure, inside our blob service in just a moment. But we also have semi-structured data. These are things like NoSQL, where there is some structure to it. So Cosmos database would be semi-structured because it's a globally distributed NoSQL. We'll talk more about that in a moment. And then we have structured data. These are our relational databases. Think SQL Server, think Oracle, think all those different things where there's a schema and they work with it. Inside of Azure, we have these different categories of storage, but how do we store them inside of Azure? Now, database services are done a little differently, but where you're going to store most of your data is in what is called a storage account. And a storage account inside of Azure spans 2 different categories. We have infrastructure as a service, IaaS services, and we have platform as a service, or PaaS services. On the IaaS side of the house, we have what is called disk storage. Remember I talked about premium storage and managed storage? Under the covers, Azure automatically creates a storage account that stores your VHD files. Now, we have another version which is called the Azure File Service, and this allows us to put an SMB file share inside of the cloud technology. Server message block is a very common way we access it. Now, if some of you are going, hey, what's server message block? If I were to tell you / server name / share name, that's server message block. And SMB allows us to access those files in the cloud. Now, exam tip 101. I don't even know what tip. I'm probably like 15 by now. Folks, If you see a question on your exam that says you want to access storage in Azure using the SMB protocol, the answer with 100% certainty is files. It's the only one that will ever speak SMB protocol. Everybody else can be accessed via APIs, but if you're SMB, files. SMB, files. Garrett, SMB?
Files.
Very good. So you would have gotten that question right. Exactly what we do inside the environment. We also have platform as a service where we contain the other types of storage. We have containers for our container storage, and our containers really are not for our container storage, for our blob storage. We have page blobs, block blobs, and that's how we're going to use and leverage the information. Under the covers, it's all about read and write accessibility, and we'll talk about that in a moment. We also have append blobs for log files. We're just going to append to the end of that environment. We have tables for NoSQL data, and then our applications need to talk to each other, and we use queues for that application communication. In other words, they have to store their messages somewhere. They use message queues. For exams, kind of know at the real high level the different general ideas what we have inside of it. But what I want to show you is how to actually create a storage account where all this stuff is created. A storage account inside of Azure is just a bucket on where we contain our resources. What can be in a storage account? Can I have structured data? Yep. Can I have unstructured data? Yep. Can I have semi-structured? Yep. It's where we store everything. It's just an account. So I'm going to go through and step through the creation of the account to show you what it is and how to use it. So let me hop back into my portal here. And in my portal, I'm just going to go into my storage accounts. And I'm going to go ahead and add in a storage account here. And give it a second to come up. And first thing, with pretty much everything you go here, what subscription and what resource group. Constant, so I'm going to say AZ Fun. If I scroll down, it's going to ask, what is your storage account name? Now, this name that you put here, and I'm just going to call it Fun Storage 1, has to be globally unique, which means in all of Azure, this name can never be used, all right? So it has to be globally unique. I give it a region. I have the ability to choose premium. If you choose premium, it does one really big thing important to your replication. It creates what is called locally redundant storage. I'll talk more about that in a second because there's a big story here, folks, that you're going to need to know how to do not only for this exam, but every exam moving forward. You have to understand what we do under the covers for replication. If I choose standard, I can have my general account time. Now, folks, you very rarely will ever change this choice. Just ignore it. This isn't the storage you're looking for, right? Standard V2. If I click on the down arrow for this, I have the general purpose or blob storage. Depending on what region you're in, we have file storage where you have dedicated storage. But remember, the storage account is provisioned to store any type of data that you want to store inside of Azure. So I'm just going to choose V2. And then we get into access tier, just real quick, and then I'm going to talk over our application. We have hot storage. We assume with Azure, anything you put inside of Azure, you're going to want to use it, and that's hot storage, so you pay a little bit for that. You have cool storage, which you can immediately access, but we recommend anything 30 days or older. If it's never changed in 30 days, move it into cool storage. It costs a little less. It's immediately accessible, but there's latency in the terms of seconds to be able to access that file inside of Azure. Now, let's talk about the replication, because locally redundant storage is the default. You might be surprised to know that everything you store in Azure, there's actually 3 copies that are stored automatically for you. 1 you only pay for, the other 2 are for us, for our fault tolerance. They're behind glass, break in case of emergency, then we'll access one of those 2 files that are available to you. But there's choices here. If I click on the drop down, notice I have a couple choices that are in preview. I'll talk about those as well. What we have is called zone redundant storage. Now, if your brain just went, hey, what? Matt talked about this thing called availability zones. That meant multiple data centers inside of a region. You're in the right headspace. What happens now with zone redundant storage, we get 3 copies of data, but they're put in the different zones inside that region. So now we have a higher availability for our storage. If we go geo-redundant storage, or GRS, we have a total of 6 copies of data. 3 in the region A, and Garrett, any guesses where those other 3 copies are?
In the peer region.
Exactly right, in the pair region that we have 6 copies of data. Now, when you do geo-redundant storage, you will double your storage cost because you'll pay for 1 copy in the region A and another copy in region, whatever it's region pair, region B, you'll pay for that. But you also pay for the initial replication, which does create egress traffic charges. I mentioned that to you because if you're replicating for the first time, if you choose GRS, you can have petabytes of data and your bill will reflect that. It's not really generally a large amount of data, but just be prepared, you do get charged for egress traffic charges. The cool thing about that is that once that initial replication is done, replication, we only replicate the deltas between the data. So we don't do full replication, just what has ever changed. So we'll generally see with customers like, hey, why is my egress traffic charge really high this month? Because you did that initial replication, and after that, it should drop back down with just regular usage. But GRS, 6 copies of data, 3 in the region A, 3 in its region pair. Then we have a variation of GRS, and it's called read access, or RAGRS. What this is, still the same 6 copy days in region A and region B, but that other copy of data up there is read accessible. So in other words, people that are in that region or close to that region can use that data. Types of things of why you might do this: you may have log files up there, maybe you have some analytics and databases. You just want people to see it. Can't change it because you can only change it in the region we created, but read access allows us to do that kind of change. When you look at a cost structure, LRS is the least expensive, followed by the most expensive, which would be RAGRS, and the different calculators will show you that. And we'll talk about the calculator in Module 4. Now, the other two here are in preview technology. Matter of fact, these previews, from what I've seen and experienced, you can only use them when you're creating the storage account. If you want to try the preview after the fact, you have to recreate the storage account. But the names tell you everything you need to know. Geo Zone Redundant Storage. When you do GRS, we just put it in the different regions. Well, if you do Geo Zone, guess what? It puts it in the different regions and the different zones. Our read access Geo Zone Redundant, RAGZRS, 6 copies of data, once again, different zones, but those zones can be read accessible. And so when we create the storage account, we have the ability to do that. So I can click on Next Networking, which allows me to control how I access the storage. Do I want all networks to generally? That's generally what you're going to do. All networks are going to want to come into it, but you can create private endpoints. Really not going to go into that, but we can control. If we know only a certain virtual network or a certain set of systems are going to access the storage account, you can lock it down inside of Azure. Advanced just controls some of the advanced options. Do I want secure transfer? In other words, we store all of our data safe and secure at rest. All the data is encrypted on our data centers. It's all there at rest automatically for you as a customer. But what if you want to make sure you have secure transfer? Is the data moving in transit? You can enable this here, and that will require access. We have soft delete for our blobs, which allow us to control kind of a recycle bin at the blob level. So if I delete a file, I can bring it back very quickly. And then we have some specific things for Azure Files. If you have a large amount of file shares or data lake storage, if you have some things, you might need some of those options. And we also have previews for NFS to access storage as well. Here's our tags for our governance. Next, review and create. Should pass validation. I'm going to go ahead and create the VM. And notice that as that's creating, we have that wonderful download template that was there for us to use. Now, this storage account, what can be inside of here? Pretty much everything. And I'm just going to give you a quick tour once the storage account is created so you can see all the different things that are available to you and why that name had to be globally unique for you to use and leverage.
Hey, Matt, question from one of the attendees. So you mentioned that there was additional charges when we're replicating data if we're selecting geo-redundant storage versus local redundant storage. But are there other times where there's additional charges other than just storing the data, or is it just during that replication?
Well, so that replication causes egress traffic charges. And it's a great question. So whoever asked an awesome question. What happens is that we always charge for egress traffic. Replication is one of those egress traffic charges. Well, what if there's a public-facing website and I have my customers pulling data out of my customer website? Just create egress traffic charges. Or if you export your virtual machines out of Azure directly, you have egress traffic. So we charge not only for the storage of the data, but also the transactionally. Now, with that said, I don't want to alarm anybody because the prices normally are fairly minimal and nominal with this, but we do have transactional charges. We have storage cost charges that are going to be there. The type of storage that you have, premium versus standard, matters. That affects storage. So it's not just about how much data you store. And by the way, we only charge you for what you're storing in the cloud. We don't charge any more inside of it, but there could be additional charges. Normally, the transaction charges surprise people the first time they see their bill, and sometimes in the tune of pennies. And if it's the first time they've replicated a petabyte of data, sometimes in the tunes of thousands. So not always a pleasant conversation, but I want to make sure you're aware of those charges. It looks like our storage account has been created, so I'm going to go ahead and hop over to that resource. And in that resource, notice that I have the ability, here's my containers for my blob storage, there's my file shares, there's my tables, and there's my queues. All that information is available to me, and you have inside the wizard all kinds of abilities to work with this. And if I go into the blob service, I can go on containers and create a container. I'll do that in a second. But why did that name have to be globally unique? Let me show you something here. If I go into properties and I scroll down, notice it has my primary blob service endpoint. So endpoints are how we access data inside of Azure programmatically. So if I want to come into a system, how do I work with it? Well, if you look at the endpoints here, and if you look very closely, notice it says Fund Storage 1, Guess what that is? That is my storage account name. Why does the name have to be unique? Because we're using it as an endpoint with a public URL. More importantly, it's followed by blob.core.windows.net, blob service. It uses funstorage.1. What's a file service? File.core.windows.net. What's the queue service? Queue.core.windows.net. What's a table service? Table.core.windows.net. That's why that name has to be globally unique, so that when we're accessing it programmatically, we have a name that's unique to that. So let me go into containers real quick, and let me just upload and create a blob. So I go into containers. Let me go ahead and add in the container here. We'll call it Hong Kong, just for giggles. Access level, by default, we have private, which means people can't come in and take a look at that. You have the ability to make it read-only, or you can make it container access, means they can see everything, read and write in that data. I'll leave it private for now, and I'm going to go ahead and click OK. And all this is a container, and all containers are ways that we can control our blob files inside of Azure. The cool thing about this is that once we create this container, now it's just a matter of uploading the blob. What is a blob? It's simply a file. So I'm going to go ahead and hop in to the blob file, and let me upload a file here, very quick to do. And I'm just going to select a file. Let me go into my pictures directory here. Let me go into Hong Kong. And I'm uploading a picture, and I'll show you what this looks like here in a moment. I'm uploading a picture of a panographic image of Microsoft's Hong Kong office, where we actually have a view of the bay. It's actually pretty stellar. I was blessed enough to go there with my good friend Steven, and we got to work with it. So it uploaded the file for me. Let me go ahead and close that little wizard down and open the file here, and I can take a look at that file available for me to use and leverage. Let me see if I can bring this file up. Go ahead and edit it, and notice that this file now is uploaded and in that store. So I see a panographic image of the Hong Kong office patio. It's actually really nice to hang out with. It was really hard to work there, Garrett, because I had to go out and look at the scenery every now and again. But this is how we can upload and work with those files. Now notice I sent private access. Have you ever had to share something with somebody? If I would have said container access or public access, this file would have been immediately publicly accessible. On all I would have had to have done is on my over tab is give somebody that URL, and it's not, so I just want to show you what it looks like. So I'm just going to open up a separate tab here. All I would have to do is give somebody that URL, and they would have been able to access that file. It's a publicly accessible. Now I have my access locked down so people can't look at it, but that's how easy it is to create storage and use and leverage it. And all blobs are just those binary unstructured files that we're going to store in Azure. So let me hop back in and let me cover off a lot of the other things that you're going to see inside of Azure and a lot of the other solutions. Now, I'm going to warn everybody here, I'm going to go a little fast because there's a lot of stuff here, but I'm going to give you the overview of things that we're going to need to do and know how to use and leverage inside of Azure. So inside of here, let me go ahead and bring up my slides again, and let's talk about some of the other things that we can store inside of Azure. Specifically, we have Azure Database Services. We have the ability inside of Azure to store lots of databases. We have a Cosmos database server, a globally distributed. It's a NoSQL database. It's table type storage. Cosmos database, when they say globally distributed, it means it can run anywhere. Most of the modern video games that we run in the world today, if you have kids, my son Mitchell, he loves video games, plays Fortnite and Destiny 2. Almost a majority of those video games run some kind of a Cosmos database or Postgres database in the back end for matchmaking, for profile information stored. We also have traditional SQL database. We have Azure SQL. Now, this one's really cool. Azure SQL Database is a PaaS service. Wait a second, Matt. SQL is a server. It is. Inside of Azure, and this is one of the unique things, one of the offerings that would differentiate us from other cloud providers. In other cloud providers, if you want to run SQL, you have to spin up a virtual machine and then run SQL on top of it. We can do that in Azure too. We can spin up a VM and run SQL on top of it. But we also have inside of Azure, Azure SQL Database, which now we don't have to worry about the server. We can just write natively to a database in the cloud. We also have a migration tool that will allow you to move data from on-prem, other cloud providers, directly into our database services. We have a database migration service to help move that data into our cloud. Now, folks, I will tell you, moving data, pretty easy to do, but understand that most likely that data is associated with some kind of application. Depending on how that application is using data, once you move it into Azure, you might just have to change the endpoint reference of that application to go talk to that database that's now in a new location. So those changes could be minimal, although those changes could be rather robust as well. We also have a marketplace inside of Azure. There's over 10,000 listings of different partners of ours, Microsoft, that have made software to do and solve problems. Remember, we talked about platform as a service where we can build solutions, but you might want to go buy a solution. What if I want to buy something? I can use the marketplace to buy those solutions. And just FYI, all those images that we create for virtual machines all come out of the marketplace. So that Windows Server image, because I'm buying a brand new license, comes out of the marketplace. What other Azure solutions we have? We have IoT, Internet of Things. There's a great little case study out there. If you want to use Bing and go search for it, do a search on Azure and rhinoceroses. Now, I know what you're thinking. Wait a second, that's not the first word association you come out. You don't think about Azure and rhinoceroses when you do that. There's actually a really good case study that uses Internet of Things and with machine learning, which we'll talk about in a moment. There's an ecological park in southern Africa that they're trying to prevent poaching and organized crime that are killing off the rhinoceros population. They actually have a bunch of devices that are strung up in trees that are motion-activated cameras that take pictures. It takes those pictures and uploads them into Azure. And then Azure takes machine learning and analyzes them. Is that a poacher, or is that a picture of a giraffe or wind loading? It's a really neat case study, but Internet of Things is used to leverage that. And we have two services. We have IoT Central, and I like to call this kind of the basic service where people are just trying to do proof of concepts. It's a general IoT service that allows you to connect and monitor and manage IoT assets. It's generally a management kind of tool, but when you want to really work with the devices, like in the case of the camera traps, you can use IoT Hub, and this allows you to have bi-directional communication with those devices to upload inside of Azure, to work with, to use and leverage inside of Azure. And so it's a managed service, it's a communication hub, so we can get those pictures from the camera, clean those cameras off if we need to, some really cool things inside of Azure. We also have the ability to handle big data inside of Azure. It was formerly known as Azure Data Warehouse. It's now going to be known as Azure Synapse Analytics, but we have Data Warehouse, which is all about parallel processing large amounts of data. Folks, when you get to large amounts of data inside of Azure, what do you do and how do you manage and maintain it? And really, any large amounts of data, you have to treat it differently. Imagine if you have a giant warehouse that has rows and rows and rows and rows of products. And let's say you're the person responsible for making sure those orders get filled. Well, what you can do, there's two ways you can approach the problem. If it's by yourself, you're going to run up and down each row until you find the product to put in the package to send out. But that's not how you want to do it. It's not very efficient. And that's what most modern relational databases are. That's essentially what you're doing, just asking the question, running up and down the rows. But when you want to do massive parallel, when you have large amounts of data, really large warehouses, you're going to have a lot of people that are going to running up and down the different rows to find those products that they need to ship out. And that's essentially what a data warehouse is, or in our case, Synapse Analytics. We have HD Insight, once again, reaching into that data and pulling out information about what's going on, finding out what's happening inside that data, looking for seasonality, looking for patterns. We also have Data Lake Analytics. When you think about a data lake, it's very similar to what a lake would look like. So you have a large lake near you, it's information at a massive level on how do I go in and look at that data? How do I actually analyze it? So if I had, like, for example, Lake Erie, and I wanted to find all the fish that were in Lake Erie, how would I ask it a question? Well, I'd use Data Lake Analytics to ask it a question to find out what's inside there and analyze that population. We also have Azure Artificial Intelligence. Now, folks, believe it or not, you use this, you may not even know it. If you're using any of the translating programs in the world today, especially if you use Bing Translator or the Teams Translator or Skype's Translator, you're using artificial intelligence and you're using machine learning behind the covers, learning how to use speak and how you use the language. If you use PowerPoint, you actually have Azure Machine Learning with design ideas. And if anybody's ever used PowerPoint recently, you throw pictures on the slide, like Garrett and I, those pictures look really good of our families. We didn't actually make that organized. We just said design, make it happen automatically for us. It was using machine learning services under the covers for us. Now we have two versions of machine learning service. So Garrett, I got to ask you a question. I want to throw you under the bus. Are you a data scientist?
I am absolutely not a data scientist, Matt.
Nor am I, and most likely you're not either. Now, there are two ways we can use this. We have the Azure Machine Learning Service. Those are for our data scientists, for people who really need to get into the math behind this. They can develop, track, train, make their own modules, make their own models to work with it. And then there's the other one, Machine Learning Studio. Notice the bottom line here, Garrett. No need to write code, all right? That's us. It's a really great way to build and test these solutions. I would imagine, although I don't know for certain, with the rhinoceroses, they probably mocked something up in Machine Learning Studio just to see if it could work. and then they did the real work inside the machine learning service that we have. For your exams, know the differences between the two, that we have no code in the studio, learning services for our data scientists and the mathematical engineers that we have. A couple other things. We have serverless computing inside of Azure. Serverless computing, we have three areas we can focus in. That's Azure Functions. How do I describe functions? A function is normally an event that's triggered by something, and it's one event comes in and one event comes out. It'll create infrastructure under the covers for us automatically. Normally, they're HTTP triggered events. They don't have to be. But essentially, hey, I create something and spin up a website. One point comes in, one point comes out for us to do and leverage it. We also have logic apps. Logic apps are another way that we can start in Azure. Now a point comes in, but I need to make a decision on that. I actually need to make a decision. Is that a picture of a poacher? Is that a picture of a rhinoceros? Or is that a picture of wind moving? When you need to make decisions on data that comes in, you're going to use a logic app to go through that workflow, that actual structure to, hey, I need to do this, that, and the other. Then we also have Event Grid, where we have a single point come in and we want multiple things. It's just a routing service. Now think about this. Think about the poacher example for a moment. They get a picture of a poacher. What has to happen? We most likely, well, that function will come in. The picture came in there. That function might have cleaned up that picture, maybe cropped it, maybe sent it along, but then sends it off to a logic app that says, or sends it off to machine learning service. The machine learning service analyzes and says, hey, look, that's a picture of a poacher. Sends it to a logic app. The logic app looks on that, makes a decision, hey, this is a poacher. Then it sends it to Event Grid. And Event Grid says, okay, that's a picture of the poacher. First event, I'm going to send it off to be stored and safe and secured so I can capture that information. Second event, I'm going to send it down to the people that are trying to go catch the poachers to get in a helicopter to go find the poacher and save the rhinoceros, possibly catch the poacher. The point about these, and it calls serverless computing because under the covers, there's machines that are running all of this information. They work in conjunction depending on what you want to do. I know in the rhinoceros scenario, they do a lot of functions to go through that routing, go through that process of making sure they try to catch a poacher. Some really cool stuff that's there. We also have DevOps services built into Azure. DevOps services used to be the old Visual Studio Team services, and what that is, it's the ability to collaborate and work with code. When you have a group of developers working together, it's not too dissimilar than people when they work together on a Word document for a common proposal or something along the lines. The difference is the type of material that they're working with. With developers, they're working with common code. And so we have to treat that a little differently. So when we want that collaboration with developers, we're going to use the DevOps services to give that, where we can use the Kanban boards, Git repositories, where we can do some load testing. We have some pipeline capabilities here. We can really get a good look at how those developers work together. We're going to use DevOps services. We also have DevTest Labs, another service for developers. And what DevTest Labs allows us to do is actually go in and give developers basically a proof of concept creation environment where they can actually go create and work with things at a lower cost. Now they're locked down. That comes with the caveat, guess what? We have to use those resources in a local fashion. We have to use them in a controlled fashion, not in a production environment. We also have the Azure App Service. This is probably the biggest thing from a development standpoint inside of Azure. Where do developers live in Azure? They live in the app services. And well, what kind of apps do I make? Well, it depends on what they're trying to do. But our web apps are there, our mobile apps, any other service that we're going to use, it's designed to run on our platforms. This is squarely in the platform as a service environment. As a matter of fact, a lot of our software as a service offerings in the marketplace, they started as an app service. A vendor simply came along, I want to make something that does things, and it's going to work inside the app service for its use. The last thing I want to talk about in this module is our management tools. So I led off with the portal and how to create things inside of Azure. That's just one of a few tools that we can use and leverage on how we get things done. And I'm going to give you a quick tour and we'll wrap up Module 2 here in just a moment. So the Azure Management Tools, it starts with this structure. Remember the Azure Resource Manager, or ARM for short. And by the way, our templates are commonly known as ARM templates. Why? Because whenever you do anything, whenever you create something inside of Azure, it goes through the Resource Manager to get that work done under the covers and the subscriptions. So the first thing we have to do against ARM is we have to authenticate into the ARM, prove who we are, and then we can do our job. And what are the tools we have? We have the portal. That's what I did to create the virtual machine, the storage accounts. That's what I went into to work with inside of it. We also have the ability to leverage what is called Azure PowerShell. This will run on your local laptops and your clients. It can be a Windows system, a Linux system, or a Mac system. to run those environments. If it has Mac, you have to have the .NET Core, but it allows us on our local systems to tell Azure to go do stuff, manage stuff, create things, work with it. We also have other tools. We have the Azure CLI, or the command line interface. This runs on top of a Windows, Linux, or Mac system on Bash or on top of PowerShell. It's another way we can work with Azure to manage and maintain that. We also have what is called the Cloud Shell. The Cloud Shell is in the portal. As a matter of fact, I brought it up. I didn't show it to you. It was there for us to use. In other words, I don't have to have the stuff loaded locally on my laptop. I can open Azure and get to the Cloud Shell. And I can open that up and run commands, whether they're PowerShell or Bash, or I can use the CLI. We also have an application. So if you go to your app stores, you can download the Azure app for another mobile experience to work with it. Now, folks, the reason I show you this, regardless of what tool you're going to be able to get into, and I don't, if you have a Mac laptop, a Linux laptop, or a Windows laptop, well, guess what? You can use any management tool. Any of them are open to games. What if you have an Android tablet? Well, you can't load tools on it, so you can't use Azure PowerShell locally, but you do have access to the portal, which means you do have access to the Cloud Shell. So pretty much everything we have, we can access the Cloud Shell. Or what if you have a phone? There's an app. Now, that app is generally a monitoring app. But guess what the app also has? Cloud Shell. Why do I tell you that? Because in the Cloud Shell, guess what? It's a browser environment with an editor that you can actually store and have a central repository for your scripts. Now let me show you the Cloud Shell real quick, and then we'll hop out of Module 2. So I'm going to hop into my portal here real quick, and I'm going to hop in my home area. Now inside of here, how do I get to my Cloud Shell? It's up here, this cute little icon. I know it's the PowerShell icon, and some people it's a square with, I don't know, a greater than sign and an underscore. I don't know. I always think like it's a duck sticking out its tongue. However you want to look. I don't know. There's lots of things you can use here for it. It's this icon. Just know this is the Cloud Shell. I'm going to bring the Cloud Shell up, and it's going to bring up my Cloud Shell. It brings a Bash up, which was my last one I went inside of it. Now, I don't know anything about Bash. I know what it stands for. It stands for Born Again Shell, which is a Linux environment. But what I do know is inside of here how to bring up what is called the Azure command line interface, where I can interact with Azure. And I'm just going to type in the letters AZ in my shell and hit enter, and it actually will bring up all the different commands. Now, I always chuckle at get this, Gary. I think this is a long lost art form, the bit art, like being able to type letters that are there. But notice I have CLI, and it gives me the information of what I can do. Now, how do I learn more about this? So I just want to give you a little bit of information here. So I'm going to learn more about this command called group. Group is how we manage resource groups with the CLI. And I'm just going to put azgroup / help. And it's going to actually bring up that information for me. It gives me the help. Well, I need to know more about this. Well, I can hit the up arrow. I have command remembrance like we do with most command line tools that we have. But I'm going to put in AZ group, and I'm going to type in the word create. That's one of the commands. I want to create a group with the command line interface. Inside of here, hit enter, and it shows me an example, the different variables I can put inside of it. Folks, the point I want to make is that when you're going to use CLI, every command begins with the letters AZ. And depending on what you want to work in, can you find out more help? -- help at the end, or tick help at the end, you can work with it. Now, if you're wondering, hey Matt, which tool do I want to use when I get into the Azure environments? Really, I recommend learning CLI. And for your exams, you're going to want to know CLI, but you also want to learn Azure PowerShell. So to do that, let me switch over to my PowerShell environment. Now, folks, I'm not bragging. I've done a lot of work with PowerShell. I have a couple books on PowerShell, a Linda course, and things like that. But I don't tell you that for that, because I actually like CLI a little bit better, and you're going to see why. Now, PowerShell we still need because CLI is not quite fully full feature yet. But let me go ahead and just clear my screen out and let me type in. Every CLI command begins with what letters?
AZ.
AZ. So I'm just going to type in AZ, hit enter, and notice I get the same bit art, I get the same command structure. So folks, the reason I like CLI, I don't care if you have PowerShell or Bash, you can interact with Azure at the same command syntax. Same exact command I typed in Bash is the same exact command I type in PowerShell. It's one of the huge advantages of learning the Bash or learning the CLI environment. Now, last thing I want to show you here real quick is if you want to learn about Azure inside of here, if you want to learn more about Azure, first off, what can you do? In any Azure, in any PowerShell, I should say, want to learn more about PowerShell here, type in git command, and there'll be a test on this. Everybody got that? Okay, those are all the PowerShell commands that I can run, Azure PowerShell commands that I can use inside of it. Now, unlike CLI, where I put the help at the end, if you want to learn more about PowerShell, a certain command, you can type in get help. And I know one of the commands that I could use to resize or work with a VM is called update AZVM. These are all called commandlets, get help. Commandlets are in kind of that verb-noun relationship. Get, set, start, restart, delete, followed by a noun, whatever you're trying to do, whatever object you're trying to manipulate. And so if I just say get help, update AZVM, it actually has built-in help for me to use and leverage. I can even have some switches like, hey, I want to have an example so I know what this looks like. Just type in examples, and it gives me that command line interface. Folks, I want you to understand that the tools are there. For this particular exam, know the differences and just a little bit about the tools. In real life, learn how to automate it. Garrett talked about the importance of leveraging the different types of technologies for repeatability. Templates are one way. Learning how to create scripts and modify and work with these scripts becomes another way that we can be consistent and repeatable with Azure. So from that standpoint, folks, you really want to learn how to use these languages. Now, if you're kind of like a free agent, you never really used any in the past, I'd recommend learning two. Learn the CLI. Learn how to use the CLI, how to find help, and then learn how to use PowerShell. If you only want to learn this because you're never ever going to real life because you're going to take the exam, learn PowerShell and learn CLI. You're going to see both of these examples in pretty much every exam you take from here on until forever with Microsoft. That's where we focus in that. Now, I mentioned with the exams past AZ900, you might have labs that'll give you tasks. We don't care how you get the task done. If you want to use the GUI, use the GUI. If you want to use Azure PowerShell, if you want to use CLI, you use whatever tool you're comfortable with. So in our exams, we don't really care which tool, as long as you know how to do the task. So with that, that brings us to the end of Module 2, where we talked about a lot of the core services. Once again, an inch deep but a mile wide. We started with the physical architectural availability zones and availability sets. We focused on virtual machines, networking, and storage. And then we spent a time talking about all the other types of solutions that we can run in Azure.
Thank you for your time and your attendance today. Today we covered Module 1, where we discussed cloud concepts, and Module 2, where we learned about the core Azure services. Join us tomorrow, where we will cover Module 3 and discuss security, privacy, compliance, and trust. And then we'll finish the day out covering Module 4 on Azure pricing and support.